Okay, so today I'm going to be talking about the ecological effects of hydroelectric dams. So first off, what is hydropower? Hydropower is the generation of electricity using the flow of water. So essentially there will be a flowing river. You put a dam on that river to create a reservoir. Water then flows through the dam, turns a turbine. You can kind of see here all these fancy vocab words. You know how it works. Just flows through, turns the turbine, that's connected to a generator, and that goes off into the grid. And then the remaining water is sent out of an outlet, which goes downstream, kind of continuing the river. But as you may know, that can come with some negative consequences. So currently 5.7% of the electricity generated in the US comes from dams. So just some brief history. The first AC hydroelectric dam was created in California in 1893. It was actually used to power streetlights at the time. This was like a marvel of technology because they were using running water to power electricity. And people thought it was like kind of crazy. This is not the first dam, but this is just kind of what they used to look like. And then you can see over here on the right, the advancement, how far we've come. This is the Hoover Dam. It was built in, or finished in 1935. And at the time it was finished, it was the biggest, tallest, most energy efficient dam in the world. That lasted for about 10 years, and then they built the Three Gorges Dam in China, and that is now the biggest. But currently the Hoover Dam provides electricity to about 1.3 million Americans, million homes, all throughout Nevada, California, Arizona, New Mexico. So it's a very valuable piece of infrastructure for the US energy grid. So what are the effects of dams on fish? The primary effect is what kind of first comes to mind when you think of blocking up a river, is that fish are unable to swim back up the river to their breeding grounds, to their migratory patterns. All of that is disrupted by blocking a river with a huge slab of concrete. So that will stop breeding, all of that spawning. There are some potential things that you can do to alleviate this, which I'll cover later on in the slideshow. But this is a big problem. I mean, salmon, eels, herring, they're all affected by this. These are just some examples, but they can't get up, they can't breed, and they can't return back to the ocean. Effects on mammals. So beavers obviously use running water. They use streams to build their homes, build natural dams. And without the consistent flowing of water, because dams release water at different intervals of time, so without the consistency, some downstream streams will dry up. Beavers can't, unfortunately, build their homes, and so they'll be forced to relocate. Otters, it's a cascade effect with the fish. So when fish start dying, when fish aren't reaching places that they've reached before, the otters obviously aren't going to be hanging around there for much longer either, because they eat fish. Effects on plants. So this is actually a pretty big effect. Not a lot of people would intuitively think that blocking a dam would affect plants, but wetlands that are further downstream and plants that use the currents to disperse their seeds are obviously heavily affected. They won't be able to go further down, and the fluctuating water levels also messes with wetlands. Dry periods and flooding periods that are not natural can kill off some species that live in wetlands. Cattails, duckweed, willows, cottonwoods are all species that are affected. So I decided to do a case study to kind of further emphasize this point of the fish impact. So this case study is pretty familiar to me because I was actually involved with this. I worked at Constellation Energy over the summer for my internship, and they operate a dam called the Conowingo Dam. There, that little star is on the Susquehanna River in Maryland, Pennsylvania. You can kind of see, this is Pennsylvania, this is where the main Susquehanna River is, but as it flows down to the Atlantic Ocean, it passes through Maryland right there. And so that's where they built the dam. This dam blocks American eels and American shad migrations upstream, and I'll talk about why that is a problem. But first, there's me at the dam. It's a pretty large dam. You can see that it's definitely made for electrical generation with all these transformers up there, and then you can see all of the outlet right there. And yeah. Okay, so I know this may look a little bit confusing, but it's really not. So I'm going to walk you through this. This chart right here on the left side is the total 2024 fish counts at the Conowingo Dam. So the three that I pointed out are the American shad, northern snakehead, and the gizzard shad. The American shad, as you can see, is kind of cool. You can see throughout the weeks of March, April, and May, you can see 0, 0, 0, and then late April, late spring is when American shad migrate. So you can see that they started picking up fish down there. The snakehead is an invasive species. They also migrate upstream. You can see they started picking them up around late spring as well. And the gizzard shad is just a common fish that lives in the stream. They go up and down. They don't have any migration patterns or anything like that. And so you can see that they just kind of consistently catch them throughout the year. What they do with the American shad, what Constellation does, what some other dams, and what most people are pushing for is the fish and eel ladders. So what Constellation does is all these fish will swim into a certain area. They will then collect these fish, sort through them. They will determine which one are American shad. They will then put those in a truck, drive them about 10 miles upstream, release them, so they're able to, do their natural duties. The snakehead is invasive, so this kind of serves a double purpose, double benefit, is that they take these snakeheads that they catch and they remove them from the river. And then the gizzard shad, what they do is they just disperse them evenly throughout the water. So they'll bring some back downstream, they'll let them go again right there, and then they'll also bring some up with the American shad as well. And as you can see over here on the right, this is a total for all of the years from 2000 to 2023. I just want you to pay attention, that's why I highlighted this. The number up here in 2000 was 150,000 American shad passing through the Conowingo Dam. Down here in 2023, we're down to 10,000. So while this is a strategy that works, and it is better than just letting them not doing anything, you can see that there is a decline in American shad. This could be due to external factors. I'll need to do further research on that, but for right now, you can see that there's clearly a decline. Next is the American eel that I was talking about. This is the second major species that is affected in the Susquehanna River. Same thing, this is the 2024 totals for the Conowingo Dam. As you can see, there's a lot of eels going through there. I actually got to see the environmental specialist at that dam. She had a bucket of eels that they were freshly loading, which is kind of crazy. They were like jumping everywhere. But then this is the total. And so with the eels, it's a little bit different. They're not really being majorly affected by this. As you can see, it's 42,000, 217,000, and then you can see a fluctuation throughout the years. They're not facing too heavy of a consequence from this dam. But the thing that is important with these eels is that the Susquehanna River has a very important species of mussel in it. And this mussel, throughout the years, has slowly moved down the river. And the only way that that mussel is able to move up the river is through American eels. So whenever the mussel releases its babies, I guess, they're like little tiny microscopic mussels, they attach to the gills of the eel, and as the eels swim upstream, they detach, and that is how they go back and forth between the water. So the eels are very important, almost a keystone species in this river, and without them, without the decline, and without them being able to move upstream, bad things happen. Mussels clean the river, and so the river will face consequences. So in conclusion, there are many benefits of hydropower. Obviously, as the world faces the climate change crisis, many people around the world are focusing on their CO2 emissions. Hydropower is a great alternative to that because there's no emissions. The fuel source is unlimited, it's just water, and there's not a lot of downsides to it, and it's a good alternative. However, we must very closely monitor the environmental impacts of these dams. You can't just start building dams all over the place because CO2 to save the planet. They will eventually, they will block waterways that could maybe lead to potential water rights issues, potential irrigation issues, potential farming issues, all of that. So we have to be very mindful of where we put them. We have to be very mindful with how we address the consequences that come from them. And we must do our best to work in harmony with nature, the environment, humans,